Hey everybody, let's look at case 3, where the denominator is a non-repeated irreducible quadratic factor. What that means is we have a quadratic equation whose solutions are complex values. In order to set up this partial fraction decomposition, it'll be in the form ax plus b over ax squared plus bx plus c. And we're going to determine the values for a and b. Now, one thing to note is that in case 2 and in case 1, the denominators were linear factors, and you saw that up top it was just a constant, so it was like essentially 1 degree less. A degree of a linear factor is 1, the degree of a constant is 0. When we have the denominator as a quadratic, whose degree is 2, then the numerator is going to be linear. So it has that nice little pattern. Alright, so when we have something like 1 over x plus 1 times x squared plus 4, the way that we're going to set this up is we see that x plus 1 is just a linear factor. So this will be a over x plus 1 plus b plus bx plus c divided by our x squared plus 4, because in this case, that's when it's the quadratic irreducible factor. And so it's going to always have that linear form on top when it's a quadratic form in the bottom. And we're going to want to multiply and make all the denominators the same. So we'll multiply by a factor of x squared plus 4 here. And a factor of x plus 1 for the last term. And so now that all the denominators are the same, we can multiply the numerators and clear the fraction. So I'll end up with we'll end up with 1 equals a, and distributing ax squared plus 4a plus, and then we have to multiply this out, so I'm going to have bx squared plus bx plus cx plus c. Okay, so same idea as the other times, we're going to equate the x squareds. So I'll have a plus b times my x squared plus b plus c times my x and plus 4a plus c as my constant. And so let's just make sure we have all that information. Yeah, so this is still equal to 1. And the idea here is, remember on this left side, it's like 0x squared plus 0x plus r1 equaling that a plus b times x squared plus the b plus c times x plus 4a plus c. And so if the equations are to be equal, we need to make sure that the a plus b is equal to 0. We need to make sure b plus c is equal to 0. And 4a plus c is equal to 1. And so when we go ahead and solve this, let's see, I think I can cancel out the b's here, right? So I can rewrite this as negative, yeah, let's multiply this by a negative, yeah, and then plus a, nope, oops. Alright, so I had a little typo, erased it, so we'll have negative b minus a equals 0, and then we'll still have b plus c equals 0. So I'm playing with the first two equations, and I noticed that if I multiply the first equation by b, by a -1, then I can add these two and eliminate b, getting an equation in terms of a and c. So this is going to give me, this is 0 here, so then this is going to give me -a plus c equals 0. So essentially c is equal to a. And so when we go ahead and plug this in, if c is equal to a, then 4c plus c is equal to 1. So 5c is equal to 1. So c equals 1/5. That means a is 1/5. And b, if a plus b is 0, then a equals -b, so b is -1/5. So this means, where can we write it? This means that, let's just clear. This means that this equation can be expressed as 1/5 times x plus 1 So we found a to equal 1/5, so we have 1/5 times x plus 1. We found b to equal -1/5 and c to equal 1/5, so we can essentially factor out that 1/5, leaving us with -x plus 1 on top divided by 5 times x squared plus 4. Alright, so that was case 3. One more case to go.